Welcome. Today, we're looking at one of the most useful tools in linear algebra, the dot product. Let's start with the algebraic definition. It's actually very straightforward. If you have two vectors of the same size, you just multiply their matching numbers and add them up. In 2D, it's simple. Multiply the x's, multiply the y's, and add the results. This logic works exactly the same way in 3D or even higher dimensions. Let's look at a real example. Take vector A with coordinates 3, 4, and vector B at 2, minus 1. Notice that we started with two vectors, but we finished with a single, regular number, a scalar. But what does it mean? That brings us to the geometric definition. Here, the dot product is the length of vector A times the length of vector B times the cosine of the angle between them. Visually, this is about projection. Imagine shining a light down on vector B. The shadow it casts onto vector A is the projection. It shows us how much of B is pushing in the same direction as A. So, the dot product really measures alignment. To use this effectively, you need to know four key properties. First is commutative. The order doesn't matter. A dot B is the same as B dot A. Second is distributive. You can break apart complex vector additions into simpler pieces. Third is scalar multiplication. If you stretch one vector by a constant, the final result stretches by the same amount. And fourth is the length formula. If you dot a vector with itself, you get its length squared. This is directly related to the Pythagorean theorem. So, why do we care? The most powerful application is the orthogonality test. Because the cosine of 90 degrees is 0, the dot product of any two perpendicular vectors is always 0. This lets you check if lines are perpendicular instantly, without measuring a single angle. You can also do the reverse. By rearranging the formula, you can find unknown angles. If we divide the dot product by the lengths of the vectors, we get the cosine of the angle. For example, take the vector 1, 1, and 1, 0. If you crunch the numbers, you get a cosine value of 1 over the square root of 2. We know from trigonometry that this means the angle is exactly 45 degrees. In summary, the algebraic method lets you calculate it easily. The geometric view helps you understand it as projection. It's the perfect test for perpendicular lines, and it's the best way to find angles between vectors.